Okay, so for this problem, first thing we're going to jump out, it's going to jump out at us is they're telling you order is not important. So if order is not important, this is not right. That is a permutation right there. It's about, there you go. So we know that cannot be right. So looking at the other way, you are particularly asking about the small fry game, which means that you match 4 out of your 5 numbers. Now, here what you've got going on is saying out of the 43, you're going to pick 4. That's not matching 4 out of your 5 numbers. That's how many ways are there out of the 43 different balls. How many ways are there to pick 4 of them? Do you hear the difference in what we're saying? So what we need to do is change this numerator. Your denominator is perfect, by the way. The denominator would be every single possible outcome. Out of the 43, how many ways are there to pick 5 balls? Done. All right, so for the numerator, though, we don't want out of the 43, how many ways are there to pick 4 balls? You want to say out of your 5 numbers that you picked, how many ways are there for them to pick 4 of those? That's what we have to make. So if that's enough of a hint for you to get yourself going, well, there you go. If that's not enough of a hint, your picture is moving on me. How dare it do that? Okay, so if that's not enough of a hint, let me kind of walk you through it a little bit. So the big idea here, what we're saying is, okay, again, like I said, denominator, perfect. 43 combinations of 5, done. All right. Now, the numerator, there, you picked 5 numbers. When you filled out your card, you picked 5. Now, but to be a small fry winner, they need to pick exactly 4 of them. So you're going to say, how many ways are there to pick 4 out of the 5? But we're not done. So imagine, let's say you picked the numbers 1, 2, 3, 4, and 5. We need them to have exactly 4 of these. So we need them maybe to pick the 1, the 2, the 3, the 4. But now we know that they've picked 4 of them. They cannot pick the 5, but they're still going to pick another number. There's going to be a number of 5 balls drawn out of this, on TV live for you to watch. So they've already picked the 1, they've already picked the 2, they've already picked the 3, they've already picked the 4. Now, let's say you're imagining you want the small fry. You don't want to be a big winner. So now you are saying, please don't pick the 5. If you pick the 5, I'm not going to be a small fry winner. So you need them to fill in something else for this slot. Well, so this first part, this 5 choose 4, takes care of this. We've got to now say, all right, how many different choices do we have to fill in the last slot? Well, so how many balls, how many numbers are there for them left to pick that will make us happy? Well, it's not 43 because we've already pulled out 5 numbers. We've already chosen 5 of them. So there are 38 remaining numbers, and out of those 38 we need them to pick 1. So you can almost think of it like this. We need them to pick 4 that you did pick. Actually, instead of putting you, I'll put did. So out of the 5 that we did pick, we need them to pick 4. And out of the 38 numbers that we didn't pick, we need them to choose 1. And that will fill in your hand. So there you go. So then for the next part, now they're saying what's the probability that you're going to be a small fry or a big winner. And the idea, what you need to understand is that small fry and big winner are both mutually exclusive events. The big winner has a probability, the small fry has another probability, and you can't be both. You can't be a small fry and a big winner. So therefore, this is an either or type situation. You can have cloth or leather. So because of that, which principle are we going to use? If you think you know it, stop the video, give it a shot. If you don't know it, it's addition, right? You can go back and think about that addition principle and what that means as far as the leather and cloth seats, that kind of thing. So it's just you're going to take your 2 probabilities, add them, and there's your answer. Okay?